We are going into lesson 7, continuing on with that. We're going to go over some graphs. And let's take a, we know that y equals to c plus or minus a sine kx, and also y equals to c plus or minus a cosine kx, where we know that c will make our graph do what?
Shift up or down.
Yeah, shifts up or down. So actually there's a plus or minus in front of the c as well. If it's plus, it'll shift the graph up. If the c is minus, it'll shift the graph down. Now this plus or minus here, in front of the sine or cosine, what does that do? It'll, well, that's, I won't.
Expands or shrinks.
Right, yeah. It does,
Expands or shrinks.
well, it does what?
Oh.
That's right, good. Reflects about the x-axis. If it's plus, it doesn't reflect, but if there's a minus there, just like if we had y equals to a negative x squared, right? That reflects the parabola down. So would y equals to a negative sine x would also reflect that graph about the x-axis as well. Okay, now A, what does that do?
Amplitude.
That's the amplitude, right. And that's always an absolute value. So you don't look at A as positive or negative. You look at A as the number of units from 0. So where A is the number, just like any absolute value, of units from 0, where 0 is like the x-axis. It's the number of units for 0 for the y-coordinate. And so if, let's say, A were if there's no A there, then it automatically, like if we had just sine, or just y equals to sine x, then A is automatically 1. And so that would put us at 1 and negative 1. Well here, this is also 1, right, for A, but you don't look at the sign, because the sign, all that does is reflect the curve. So this would also be considered 1 to negative 1 as well. Okay? Alright, well what if we had y equals to 3 cosine x? Now, A equals what? 3. And so now this is 3 and negative 3. And so our curve is going to oscillate between 3 and negative 3 from 0 as like our center line. Okay, now the k. What is that going to do for us? Yeah, it affects the period, right. So k In other words, it does, or it also would affect the horizontal compression and shrinking. So we would look at the period as 2 pi over k. Alright, so if as k gets larger, what happens to 2 pi over k? As k gets bigger, right, like 4, 8, 100, now what happens to the period? It shrinks, right. The fraction gets smaller. As the denominator gets larger, the period gets smaller, right? Because if you had pi over 50, right, that's smaller than 2 pi, right? Whereas if k is a fraction, then you would flip it and multiply, and so you get horizontal stretching. All right. Okay. So we need these two models here, these two here, to help us out with our graphing. Alright, so let's take a look at some problems. Let's say that we have